Solubility of ionic compound, covalent compound, and gas. This topic I'm talking about those ionic compound, covalent compound, and gas. Are they soluble in water? Are they soluble in water? That's what we're going to talk in detail. Ionic compound. What is ionic compound? Ionic compounds are made of positive ion and negative ion and bond together by the attraction force. Some of the ionic compounds are soluble, but later on we will study more that is some insoluble ionic compound that I will refer to the solubility rule later. But in general, at this stage, we assume ionic compound as soluble. When ions in water, the ions are separated by water molecule. That's we call soluble in water. In this process, we call dissociation process. This a block of ionic compound. A block of ionic compound, they dissolve in water. And now they become separate into an ion. And that is called the aqueous. We've been mentioned. In equation, this a block of NaCl. Now they become separate into an ion surrounding by water. They become an ion surrounding by water. That's what we call aqueous. Now let's talk about solubility of the covalent molecule. Is covalent molecule soluble in water? Now let's see. You will see some covalent molecules soluble, some only partially soluble, some are insoluble. What does that mean? That means I didn't give the answer. Then what is depend on? It depends on the polarity of the molecule, the polarity, and the intermolecular force between its neighbor. Does this word sound familiar to you? Polar covalent molecule like ammonia, methanol, ethanol, glucose, they form hydrogen bond with water and are soluble in water. Now explain. Remember the electronegativities, water as a polar molecule. Water as a polar molecule because of the unsymmetric electron distribution, remember? So O is more negative, H more positive. So you see in this polar molecule like ammonia, they are polar molecule. NH, unsymmetric. Methanol, you have a OH, which is much like water, not unsymmetric. Methanol. Ethanol also have a OH group, unsymmetric electron distribute. Same as glucose, sugar, you have lot of OH group. All these OH group are very unsymmetric in electron distribution. As you see, OH O 3.5, H 2.1 electron negativities. So you put in water, what will happen? Ammonia will be surrounded by water. Methanol, the OH part was surrounded by water, same as ethanol, surrounded by water, same as glucose, that's surrounded by water, and they all soluble in water. Now let's look onto the other side. What about those non-polar substances? The non-polar substances, they are not soluble in water. Water do not attach to it. As why they non-polar? Because look onto this CH. Very symmetric electron pooling. All these CH hydrocarbon group. So in these three non-polar substances, methane, ethane, propane, they are non-polar, so they are not soluble in water. Now let's talk gas. Is gas soluble in water? Gas generally are non-polar molecules. They are less soluble in water. If they soluble, it will be only slightly only. They do not form hydrogen bond. They form dipole-dipole and dispersion force. So now let's explain. Electronegativities. What is this non-polar molecule mean? What's this non-polar molecule mean? They are symmetric. So they have this symmetric make the electron even distribute. So they are not the hydrogen bond type, but rather they will be the dipole-dipole or dispersion force type. So example, O2, oxygen, N2, nitrogen, they are all partial soluble covalent molecules. They are only partially soluble. In fact, you can say they are quite insoluble. They are because why? They are a non-polar element or a non-polar compound. So they form dispersion force. Dispersion force, according to light dissolved light rule, they are not soluble in water. Very, very limited solubility. Another group of non-polar substance, methane, butane. In these two examples, hydrocarbon, very symmetric electron pooling. So they form dispersion force. Again, dispersion force. So not soluble, very limited solubility. Chloroform. This one will be a little bit more soluble than the early one. Why? Because you have a Cl, and a C. Look at Cl. Cl is 3. C is 2.5. So you can see they are slightly polar. You can see they are slightly polar. But are they like the water OH type soluble? No, they are only partial polar. So the most they can form will be a dipole-dipole force. So dipole force will be slightly soluble in water. A bit better than the early two examples, and this one will be a little bit more soluble. But is it as soluble as water, as hydrogen bond type? No, they're not. So on this table, there is some solubility of gas in water. As you see, hydrogen, how soluble are they? That much. I give you what is a soluble, like HCl. This is soluble. And if you compare HCl with hydrogen gas, that you can compare these two, you can see how soluble they are. You can say not soluble at all. As in, how about oxygen? Not soluble. And you expand onto the lower group, they will be a bit better, will be similar to this dipole substance, slightly polar substance. And I hope that student can understand. And student, please keep in mind these electronegativities causing polar, partial polar, or non-polar is very important concept. It directly affecting of hydrogen bond between neighbor, or dipole force between neighbor, or dispersion force between the neighbor molecule. Thank you.